Simultaneous equations are something you should have come across in a GCSE, where you have two equations wherein you don't know two of the variables. Now, because we don't know either of the variables in either equations, neither x or y in either case, other than the fact that it's the same value of y and the same value of x in each equation because of the same letter, we cannot solve as is. We would need to eliminate one of the letters. Now, if you were given something like this, what you're going to do is make one of the letters the same as each other. So let's say we made the x the same. You can times this second equation by 3, and that will get you 3x plus 6y equals 36, with the original equation still on top. And you could minus these equations from each other. So 3x minus 3x is 0. Y minus 6y is minus 5y, and 2 minus 36 is minus 34. You then divide by the minus 5 and you get a y value, and you can substitute that y value back into the original to get an x. That's relatively straightforward. You just have to be aware of which thing you're going to times by what to make the letters the same, and then to correctly either minus or add the equations to eliminate that same term, and then don't forget to sub back in to get the other one. But what if this wasn't what you had? What if instead it was just x plus y equals 2, and then x squared plus 2y equals 12? Now, because we have a squared involved, we cannot make the letters the same as each other, or at least in the same way. We cannot stand up minusing the equations. We're not going to square the top one because you'd have to square the whole side, not just the x. We're not going to square root the bottom because again that would just lead to complications. Never try to square root in these cases. And while you could make that the y's the same, you could times this by 2 to make this 2y. You then couldn't do 2x minus x squared because they're two different powers. So what we're going to have to do instead is do simultaneous equations by substitution, which again you potentially came across at GCSE, but we're just going to recap here and also see how we might take this a little further. So what I mean by substitution is to say we're going to take this first equation and rearrange it. Let's say that we were to have that y equals 2 minus x. So we've taken this x, we've moved it onto the other side to get the y isolated on its own. Now that we know that y is the same as this expression, we can substitute this into the second equation to therefore say that x squared plus 2 lots of 2 minus x equals 12, because instead of the y we know it has that same value. Just expand the brackets, you get x squared plus 4 minus 2x equals 12, and bring everything onto the left hand side and keep it in the right order, i.e. descending powers. You've got x squared minus 2x, and here as the 12 moves over the equals sign, its personal sign changes, becomes a minus. 4 minus 12 is minus 8. This equals 0. What we've now got is a quadratic, and a quadratic we can factorize. Because it's x squared, you're just going to have x and x at the beginning, and we're then looking for factors of 8 which could be then added or minused to make 2, or minus 2. So factors of 8, that's 2 and 4. If we want to make minus 2, we could say that's a plus 2 and a minus 4. I think there's 2 minus 4 minus 2. As these then times together to equal 0, each of them individually as a bracket must equal 0. So x plus 2 equals 0, and x minus 4 equals 0. Solving these, you then get x is going to be minus 2, and x is going to be 4. We have two possible x value solutions because there was a squared in there. We're not done though, because we now also need to find the y values. So if we just sub these, say, back into here, so y is going to equal 2 minus minus 2, and y is going to equal 2 minus 4. That gets you y values of either 4 or minus 2. If we just want to represent our answers in coordinate form, therefore, it depends on how the question is phrased. you could say that your solutions are -2, 4, and 4, -2. Okay. That's basically what we're going to have to do in this case. If you want another example, this time showing that we can actually get the x and y times together, we can look up here. So y equals x minus 4, and then 2x squared minus minus xy, sorry, equals 8. Once again, though, we're going to start by just doing some substitution. We already know here that y equals x minus 4. We already know that's a phrase in terms of a single letter, so we can go straight into a substitution. So 2x squared minus x times x minus 4 equals 8. Expand the brackets. 2x squared minus x squared plus 4x, because minus times a minus is a plus, equals 8. And then bring everything together. 2x squared minus x squared is just a single x squared plus 4x, and then that becomes minus 8 to equal 0. Once again, we have a quadratic. This time, though, we cannot break it down into two brackets, at least not very easily. Because if you go through the factors of 8, so you've got your 1 and your 8, or your 2 and your 4, neither of those have a difference of 4 that you can make in the middle. So instead, we're going to have to use a quadratic formula. So if we remember, that's going to be, so minus b plus or minus the square root b squared minus 4ac over 2a, where in our case here, a is going to be 1, b is going to be 4, and c is going to be minus 8, based on the coefficients here. So 1 for a, 4 for b, and minus 8 as a whole for c. Plugging this in, therefore, we get minus 4 plus or minus the square root, 4 squared, minus 4 times 1 times minus 8, and this is all going to be over 2 times 1 to give us x, and from this we get that x is minus 2 plus or minus 2 root 3. Now that we have our two x coordinates, so minus 2 plus 2 root 3 minus 2 minus 2 root 3, we can just plug in for the y values, putting it back in here. Because y is x minus 4, you're going to get, therefore, that y is then just minus 6 plus or minus 2 root 3, because minus 2 minus 4 is minus 6. So yeah, you just, in this case, we'll follow through with the same steps. If you have the two letters actually times together in a single term, then again, you're just still doing that substitution. There's nothing to worry about. And if you get to a quadratic here, which doesn't want to factorize, just as you would with any quadratic that doesn't do so, we'll plug it into the quadratic formula, and then just make sure to put it back to get the other letter. If you're good with that, let's just see how you're getting along with an example of your own. So down here, we have y plus 4x plus 1 equals 0, and that y squared plus 5x squared plus 2x equals 0. Pause the video, have a go for yourself, think about what we may want to do for this, and then press play again when you're ready to compare. So what we first of all want to do is we'll rearrange the top equation, because that's the one that doesn't have any squares in it. Let's say we just make y the subject. So y equals minus 4x minus 1. Substituting that into here, you therefore end up with minus 4x minus 1 squared plus 5x squared plus 2x equals 0. Expand the brackets. Minus 4x times minus 4x is going to be 16x squared. Because minus 4 times minus 4 is 16, x times x is x squared. Minus 4x times minus 1 is positive 4x, then minus 1 times minus 4x is positive 4x. Put those together, you get 8x in the middle. And then minus 1 times minus 1 is positive 1. And you still have the 5x squared plus 2x equals 0 afterwards. Bring together the like terms. 16x squared plus 5x squared is 21x squared. 8x add 2x is plus 10x, and then you've just got a plus 1 here to equal 0. We have our quadratic. Now at this stage, if you wanted, you could just put this in a quadratic formula, but this one actually does break down into two brackets. Yes, we do have a coefficient in front of the x squared, and it is a 21, this is a bigger number, but if we want, we can start just by looking at what's going to go at the end of the brackets. Because we have to times together to make 1 at the end, and we're going to presume we're going to be using integers because we don't want to have to think of fractional factors. The only things that make positive 1 are going to be 1 and 1. The plus here means the signs are the same, and this plus in the middle confirms that they're both pluses. So plus 1, plus 1. So the values that are going to add together to make 10 must come from the factors of the 21. Okay, because it'll be something times 1, 1 times something, then they add to make 10. What are the factors of 21? We have 3 and 7. So if we have 3x here and 7x here, so 3x and 7x, 21x squared, and that's 3x and 7x, because they're both 2 times by 1, add together is the 10x, and then 1 times 1 is 1 at the end. From this, like we just did here over the left, we can then just determine what the x values are going to be. So 3x plus 1 equals 0, or 7x plus 1 equals 0. So minus the 1 over and divide by the 3, you get x is minus a third, and minus the 1 divided by 7, you get x is minus 1/7. To round up with, we now just plug it back into, say, this expression here. So y equals minus 4 of minus 1 over 3 minus 1, and y equals minus 4 of minus 1 over 7 minus 1. Plugging these in as solutions, you should get that y is a third and minus 3 over 7. Okay? If we're good with that, let's just see how an actual question might look. So given the simultaneous equations, 2x plus y equals 1, and x squared minus 4ky plus 5k, where k is a non-zero constant, show that x squared plus 8kx plus k equals 0. So, as we can see here, we now have yet another unknown that they can throw at us. Not only do we not know what x and y are, other than that they're the same in each equation, we don't know what this k is in the second one. That doesn't matter immediately though, because in part A, we're just looking to create this quadratic, and as we can see, k is still very much present. We haven't worked out anything for it yet. So, we're actually just going to start, as we usually would, by substituting, or rearranging so that we can substitute. Given that this is a show that, we already see the form we're trying to get into. So we can see that we're trying to get it in terms of x. So that confirms that for this first equation here, if we can make it y equals, then we can replace the y here. So y would equal, if you minus the 2x over, so minus 2x, and then the 1 stays a positive, because you haven't done anything to it. Now we substitute into here, so you get x squared minus 4k, and instead of the y, we use that whole phrase of minus 2x plus 1, and plus 5k equals 0. Expand the brackets, x squared, and then minus 4k times minus 2x. So the minus 4 times the minus 2 will be a positive 8, and you've still got your kx. And minus 4k times 1, which is minus 4k, plus 5k equals 0. Bring the like terms together, x squared plus 8kx, and minus 4k plus 5k just leaves you with a single k to equal 0. We have shown the quadratic. Now that we have this, given that it has equal roots, find the value of k. Now there's a couple of ways we can think about this. When we're talking about the roots, we're talking about the x values we get from the brackets we can break it down into. So in other words, if it's equal roots, the brackets will be identical to each other. If we were trying to break down this quadratic, obviously we have to start with x in each case. And then if they're identical, the middle term would be split exactly in two, right? So we'd have plus 4k here, plus 4k here, because x times 4k is 4kx. 4k times x is 4kx. Add together, that gives the 8kx. That equals 0. However, if we were to expand this, you've got your x squared plus 4kx plus 4kx, but at the end, 4k times 4k would give 16k squared. Therefore, we can say that 16k squared must be the same as this k from the original. That's the only difference, yet they're going to be the exact same expression. We'll solve that in a second, but the other way you can think about it is using the discriminant. So the discriminant is an equation which we can use to determine how many roots an expression is going to have, a quadratic will have. The expression for the discriminant itself, if you're not familiar, is b squared minus 4ac, which you should recognize from the quadratic formula. If it's greater than 0, then there are two roots. If it equals 0, there's one root, or in other words, equal roots. And if it's then less than 0, there's no roots. So it doesn't solve. Because we know it's going to be equal roots, we know the discriminant would equal 0. So from this, the b is the 8k, so 8k squared, and minus 4 times the a is 1, and then your c is k, is equals 0. This becomes 64k squared, and here's minus 4k equals 0. And if you cancel through by a factor of 4, you end up with 16k squared minus k equals 0. Add the k over, you get straight back to this expression from before. So now that we're back here, you end up divide through by a factor of k, you get 16k equals 1, so k equals 1 over 16. To wrap up with, because we now know that k is the value of 1 over 16, for this value of k, find solutions to the simultaneous equations. Well, we can now say from these factors here, therefore, that that should have actually been x plus, and then 4 times 1 over 16 is going to be 1 over 4, so a quarter. So if that was to each equal 0, because they're the same thing, x is going to equal minus 1 over 4. Plugging this back into this equation from the top, therefore, y equals minus 2 lots of minus a quarter plus 1. Minus 2 times minus a quarter, minus times a minus becomes a plus. 2 times a quarter is going to give us a half, so it's a half plus 1, so it's 3 over 2. X is minus a quarter, y 3 over 2, in other words 1 and a half.